All right, hope everyone's had a good day so far. We're going to get into a topic that's near and dear to my heart, which is migrating customers to Amazon DynamoDB. We call this the applied live migration because we do have a demo today. We're going to show you one way to move an application from Cassandra to DynamoDB. We're going to talk about how to analyze the Cassandra clusters in place. We're going to talk about the Cassandra terminology and how to map that over to DynamoDB. And we're also going to cover the basics of Apache Cassandra's ring topology, replication, consistency levels. So there's some expectation that you know a little bit about DynamoDB. So the average audience member will know a little bit about DynamoDB, maybe coming from more of a Cassandra background. So this is a pretty loaded question. Why migrate to DynamoDB? There's many reasons why customers will move on to DynamoDB from Cassandra. A lot of times it comes down to a new agreement that's been signed to move all in on AWS, and then the decision is, do we lift and shift our Cassandra cluster onto EC2, or do we migrate to something like Dynamo? In my role as a solutions architect, I run into customers who are often very new to Dynamo, and sometimes their company has just been purchased by another one that's all in on AWS. So we have to make the decision, how do we migrate this application to the cloud? Now, a lot of times when customers start with a database, when the first database they ship with, it looks and sounds great. I take this picture here. This is Fernando Alonso. He was in Formula One, the World Drivers' Champion in 2005 and 2006. He really had a great start, and he's actually still racing today, but he hasn't won the World Drivers' Championship since. He's struggling for speed in his McLaren. This is the 2017 McLaren. And in fact, this will be his last year in Formula One for those of you who follow the news. Think about this. Is this the database you started with? It had great features and promise. It might even have delivered a few wins for you. And then you run into problems with the reliability, which leads to lost revenue. Perhaps you have performance impact, which leads to an inconsistent user experience. It's also really difficult to hire DBAs or engineers. There's a lot of money spent on things that don't matter for your customers. What you want is something that runs well, wins races, and is on the upswing. And not only looks nice like this Ferrari, but it delivers win after win. For those of you who don't know, Vettel's one of the best drivers in the field, and this is him driving his car. And he's fighting neck and neck with the reigning World Drivers' Champion for the 2018 title. Compared to Alonso, Vettel has a faster Ferrari engine with technology so advanced, experts hypothesize they have an 80 horsepower advantage over the next best engine. And this advantage has been used again and again to eke out race wins and put Vettel in title contention. Now, what you need is a new engine. You need it highly tuned. You need a team of skilled engineers to keep it running every hour. You have to make it over the finish line after all. Most of all, you need countless man hours from a talented R&D department to drive continuous improvement. That desire for performance brings customers to DynamoDB. They're looking for a new database engine. They stay because of the zero maintenance model and consistency, regardless of traffic load or how many indexes they add or tables they back up. Now, it's not only my opinion. Here's some real things that customers have said about DynamoDB, some gains that they achieved. Companies like Nike and Samsung have moved on to DynamoDB, as well as smaller companies in the visual intelligence and ad tech industry, such as GumGum. A company like Nike looks at moving on to DynamoDB, and they consider the engineering effort required to maintain Cassandra, and that they realize the more hours they put into Cassandra, the less time their developers can spend delivering features to customers that matter. If there's a buggy patch that they roll onto their cluster, it leads to lost revenue. If they are trying to find an engineer who's specialized in maintaining Cassandra, even DataStax Enterprise flavor of Cassandra is less time delivering features that matter. Now, after all, there is a demo. It's called Applied Live Migration. So we're going to end with that today. I'm going to show you some source code. It's not currently open source, but it's something that you can kind of review, and you can always look back at this webinar for future reference. So here's our plan for today. We're going to do an overview of Dynamo and Cassandra. We're going to dig into the cost, and the cost is always important because whenever I had a customer say that they wanted to spend more on DynamoDB, everyone wants to save money along the way, and a lot of our customers have. And then we're going to show you a pattern for live migration, just one example, and then end with a demo using some IMDb titles, such as movies and TV shows. We're going to read and write those onto an API. So this kind of slide is always in presentations on databases. When we're trying to talk about a migration, we want to compare some common terms to something that Dynamo architects like myself really understand. So when you look at here, one thing that I want to call out is that in Dynamo, everything sits inside your account, and you interact with your data inside tables. Compare this with Cassandra. With Cassandra, you've got a cluster. A cluster is like a group of servers that work together. So Dynamo is more like a software as a service. You see that in our read and write APIs. Those are almost like REST operations: get item, update item, put item. And compare that with a more familiar SQL syntax that something like Cassandra has. There's a lot in common. What you see between these two, there's actually a lot in common between DynamoDB and Cassandra in terms of the primary keys and the indexes. This is one of the reasons why we find customers who are running Cassandra can migrate quite easily to Dynamo. It's a very minor application change. It's often just converting data types to data types that are supported by DynamoDB. So in terms of heritage, we do have some of a connection between Dynamo and Cassandra. We'll dig into that later. Now, why DynamoDB? Why do customers use this service? Well, first of all, it's fully managed. And so what this means is you have a table, you have a set level of throughput, you don't have any maintenance, you don't need to hire anyone to sit and stare at a dashboard, and you have a lot of built-in innovation. Features like backup and restore, point-time recovery, which was released this year, global tables, which was released last year and recently introduced in new regions, so you can have one consistent global view of your Dynamo table. The service is high performance, and I really want to call this out because compared to Cassandra, every feature that Dynamo has scales. If you want to operate at 1 million requests per second, your latency is in fact going to be lower than running at 100 requests per second because of the way that we can cache some metadata about your requests. So our service is going to work the same whether you've got 3 nodes behind it in Dynamo or 10,000. And I'd be remiss if I didn't point out that here at AWS, security is our #1 priority. And with DynamoDB, you have the full support of IAM policies to restrict access to your Dynamo table. And this is actually something that scales. So you don't have to send out username, passwords, and endpoints. Instead, you just say, I need to connect to Dynamo and US East 1, and here's my set of credentials provided by IAM. It's actually really amazing. So if you wanted to create a policy that allowed you to update your table between the hours of 10 and 10:15 a.m. on a Sunday, from a particular IP address, and in fact, you can only update one attribute in a row, you can do that. And after you get those credentials and you make that call, you can make another call to revoke those credentials. It's all with the power of IAM. It's built in, so all the innovation that comes from IAM, DynamoDB can benefit. And of course, Dynamo data is encrypted in transit and at rest. Our backups are encrypted as well. And we have many HIPAA compliant and PCI services running on DynamoDB today. So if you want to run your tokenization service and store those that encrypted token data on DynamoDB, you can do that. We have many customers doing it today. So if you weren't using DynamoDB, this is everything that would be under your purview. A lot of customers who come to the solutions architects, they face problems with servers, with configuring new EC2 instances, with qualifying new EC2 instance families and benchmarking. Because a lot of times, if you go to a new EC2 instance family, such as C4s to C5s, what you get is for the same dollar more performance. And then there's a lot of headache around EBS volumes, which Dynamo doesn't use EBS. We don't run on EC2. There's a lot of concern about managing the alarms and all the metric data. And that's something that you don't have to deal with DynamoDB. There's no such thing as an insufficient capacity. You just make sure your account limits are high enough. Whatever capacity you request, we handle it for you and provision it in the region. Now, here's a big difference between Cassandra and DynamoDB in terms of our topology, how the data is laid out inside AWS's data centers. This is a very common misconception. It's very important too. DynamoDB is consistent and partition tolerant in the CAP theorem. So consistent and partition tolerant means that whatever you give us, we'll give that exact value back to us. We don't have problems with consistency. We won't accept a write and durably store it unless we can ensure that is consistently stored. Compare this with something like Cassandra, which is highly available and partition tolerant. So the difference with Cassandra would be with, let's say you're doing a read operation, you might need to check a couple of replicas to figure out what the copy of that row is, what the latest value is. But with Dynamo, we always know what the latest value is. We don't need to ask around or reach a consensus. So here's how it works when we store data in DynamoDB. We've got this consistent hashing scheme. It's very common. Cassandra has this as well. We run your key. This is an orders table. This is an ASIN for I think a Fire TV, but you can search it as well. And we run it through a hashing function. In Dynamo, that will fall on exactly one partition. And so there'll be one node who's responsible for that data. So we're going to durably store it in 3 places, and then we're going to acknowledge that the write was complete. And then when you want to do a read, you pick any of those nodes. So the real takeaway here is that in DynamoDB, we have a really different topology from the Dynamo 2007 white paper and from Apache Cassandra. Dynamo also has global tables. Now, global tables is a cool feature. We announced it at reInvent in 2017, and we keep adding new regions. And global tables allows you to reach a consistent state in a table all around the world, wherever this feature is supported. It's a multi-master, fully replicated NoSQL database, completely managed. So you create a global table group, define what the provision capacity is, and then auto-scaling will be enabled by default on all those replicas. And then you can choose whether you want to write from your application in USD1 or over in Dublin, depending on where your data is entering your application. Now, we'll come back and talk more about DynamoDB. Let's dig into DataStax Enterprise, try to disambiguate that from Apache Cassandra. So DSE, that's DataStax Enterprise. It's from the company DataStax. Shout out to all the people watching this who work for DataStax. I want to draw a line between Apache Cassandra and extra features that DataStax Enterprise adds. Basically, DataStax Enterprise has a flavor of Apache Cassandra, and there's no guarantee that Apache Cassandra, the public source version, is always going to match what DataStax wraps in to their release, their paid release, but it's something that they're kind of going forward are going to change. So let's talk about Apache Cassandra, then we'll dig into DataStax Enterprise. So Apache Cassandra has a SQL-like syntax for DML, the manipulation of the data, and the DDL, which defines the table schema, like your create table statements. It uses a ring topology. It has tunable consistency, which are really big topics, which we're going to cover next. And it has a consistent hashing scheme, which we're also going to cover, but we also sort of touched on it with DynamoDB when we showed you kind of our hashing system. It does have a basis on the 2007 Dynamo white paper. And just by lineage, you had the 2007 Dynamo white paper, and then shortly thereafter, you had Apache Cassandra. And then later on, 2012 was when we released DynamoDB, which is just an evolution on that Dynamo white paper. DSE has a lot of very interesting features that customers like. You have a graph database plugin. You can do search. So if you want to run Solr on these nodes and index all the data in your NoSQL database. You can also run analytics queries if you want to use MapReduce. It also has tools that are sort of similar to what you'd get with the AWS management console, such as Ops Center, which lets you manage the cluster, and DataStax Studio, which lets you. It's like a Jupyter notebook, but to handle CQLs and write SQL statements. There's a lot of other tools that you have to use in order to manage your cluster. So you have to manage nodes, data, you maybe want to benchmark. And so there's a lot under the surface, as we'll show you later, that come with managing the cluster. A lot of you guys are probably experts on it, but we're still going to cover it. Now let's do an introduction. Let's really talk about Cassandra. So inside Cassandra, there is a cluster. A cluster is a logical container, it's also a physical group of nodes working together. Now, inside a cluster, you have keyspaces. Keyspaces are kind of like databases. And then inside a keyspace, you have a table. So a key space could be like production, another key space could be dev. You can choose some settings between the two key spaces. So a cluster is made up of one or more key spaces, and a key space has one or more tables. Clusters are really tied into EC2 instances. They're made up of EC2 instances. So we'll call these nodes. A node could be something like an i3 4XL. A lot of times customers will use instance store volumes. That is another talk though. Why do we use EBS versus instance store volumes? The nodes are all equal in the cluster. I mean, with the exception of the seed nodes that will exist in each account. And an important thing to talk about is replication factor. Replication factor determines how many copies of data are maintained inside the cluster. So what you can really learn here, what we're trying to show you in these pictures, is that there's a ring architecture. The nodes work together. They are kind of interchangeable. And whenever you're inserting into data, you have a coordinator, and then that data is replicated according to the replication factor. So we're going to kind of use this diagram, flip it around a couple of ways here, and kind of teach this concept. Cassandra uses a consistent hashing scheme. So what they have is an hash function that depends, that you kind of get to choose. There is one chosen for you by default. And its output, you can consider it to be kind of pseudo-random or random-like. It doesn't have to be completely random. And the output of that is called a token. So if I take these three items, notice this is a customer orders table, by the way. This is what we used, the data we stored in Dynamo, but now we've kind of rearranged it. It's now a Cassandra table. And the output of that will be a number on a continuum. Not a continuum, but it'll be a min and max range. And those rows will all fall onto one section of that token range, and there will be one node that is responsible for it. So if you don't have that token, if you don't have that key to determine that token, then you actually have to scan A, B, C, and D. So knowing what the key is, the primary key, is very important to retrieve data from Cassandra as well as DynamoDB. So let's dig into one example. So let's look at Murmur 3. It's the default. It has a very wide range of values, -2 times new to -2 to the power 63 to +2 to the power 63. So a token value there's a token that comes out of this hashing function, and all the possible token values are arranged in a ring. Now that is actually the continuum that I was referencing earlier. A single virtual node is responsible for one section called a token range. And then an EC2 instance has many virtual nodes working together. So what you can see here is that you have an EC2 instance, and piled on top of that is nodes. And nodes are logical. You know, in this case, I have node A, D, and B just sitting on this instance. And so we'll dig into why you might have a node on a particular instance. And spoiler alert, the ring topology helps us to make that determination. So what you'll see here, as we talk about data duplication in Cassandra, is that with, let's say, a replication factor of 2 in this ring, you see C is on one EC2 instance, and then below it, C is on that one. And that's actually how it works in Cassandra. So if you have a replication factor of 2, we find which node is responsible for that particular copy of the data, and then the one immediately after it in the ring has the second copy. Now look at the replication factor of 1. In that case, only one EC2 instance will have that node. And then further, if you look at the replication factor of 2, and you see, okay, we're going to insert C, we're going to send that to a coordinator node, which is just any node on there, is responsible for replicating the data. It's going to fall on exactly one node. In this case, in this ring, that has to be on the EC2 instance. It goes into C. And then the EC2 instance directly after that in the node, that's where it's going to fall. So data is only written to the corresponding nodes. We don't replicate data throughout the cluster. And we actually use that ring topology to decide where the data is replicated. And I am a DynamoDB solutions architect, so apologies if I mixed up any wording. Now, what they say about Cassandra is that it's a tunable consistency. The consistency level, the CL, can be decided on each operation. That means when I'm doing my SQL SELECT and my SQL INSERT, I can say I want a quorum, or I want only one node to tell me what the value is, or I want all. And so you can imagine what the implication here is. If you ask for all nodes in your all nodes, you're going to get a copy of the data from all nodes that are responsible for it, which is equal to the replication factor. So if my RF is 3 in this example, as it is for all of these, then I need to contact all 3. Now, that can lead to some issues. What if one of those servers is down? Well, you might say, I just want to get a copy of the data. No, there's some issues here, because if you just retrieve one copy of the data, or you only write to one node, if that node goes down, the write may not be replicated. In this case, it has a risk. Also, if you're doing a read and you're only choosing one copy, it's possible that that read may not have been repaired, and you could have a stale value. And the quorum, of course, is just trying to get a majority of the data back. And when you're looking at Cassandra, this is the equivalent of the describe table. We're going to do a describe table call. And what strikes me here, and I saw this in my customers as well, they were showing me their code, is that you create that section on the top. You do the create table, as you see there. You got a primary key in that little green box, but there's an iceberg of settings underneath. There are so many things that you actually have to code for, and we don't have this in Dynamo. You go to Dynamo console, you do a create table statement, gives the capacity, and you're out the door. Don't have to choose compaction strategies. So it's inevitable that you're going to take these and you're going to apply them to your change management system. You're going to have to do code reviews. Oh, what happens if we change the read repair percentage to 0.1? So it's a realistic consideration. Now, let's take one step up. We look at the table. Let's look at the key space. So the reason why we're going to look at the key space, really getting to the point of this presentation, is how do we migrate to Dynamo? Now, if we want to migrate to Dynamo, we need to know how much data we have, which is actually a really hard question to answer. So there's this thing called replication factor that I mentioned earlier. It's going to come up again and again. So the replication factor determines the number of copies of data that are kept. So it's decided in the replication setting on the key space, and inside there is also the topology, and the topology varies based on whether you're running on EC2 or your own on-premise data center. There's these things called snitches that help distribute data based on your topology. And so the replication factor determines basically how many copies of data you have. So if you describe your cluster and you find out I've got 10 terabytes, but if your replication factor is 3, you might have about 3 terabytes, but there's a lot of caveats to that, which we'll dig into. You also can optionally disable the commit log. I don't know who would do that, but it's important that if you write your data to like a single node, and it's important that it actually makes it onto the disk. So the commit log, I would say, is going to be very important. Now, this slide is like many others, like the other table I showed you, is common to all kind of presentations about database migrations. We just try to show you what the equivalent data types are in Dynamo. Now, the one thing that comes up is that from our customers is that Dynamo has not a lot of data types, and that's true. They are very simple. We have strings, numbers, binaries. We have sets of all of those. We also support bools, nulls, lists, and maps. The most common question I get is, what do I do with a timestamp? A timestamp can be stored as either an epoch number, which is the number of seconds since Jan 1, 1970, or as a string using the ISO 8601 format. And for those of you taking notes, I actually have a slide later which you can review, which has the format and kind of has the tip there. So we covered Dynamo Cassandra. Now we're going to really dig into the cost. Why? Well, like I mentioned earlier, nobody ever told me they'd like to spend more on Dynamo this month. So if I know how much data I have and what my throughput's going to be in Dynamo, it's really going to help make the justification to even do a proof of concept. So to discover what the schema is actually quite easy. Where the complexity comes up is determining how much data is stored in the cluster. There's a lot of factors here, and so that's why any estimate is just going to be a guesstimate, because we're not really sure. So if you're looking at the data in place, you want to determine what the row width is, which is the number of columns under the same key. And you're going to determine this by random sampling. Get me a couple rows here, a couple rows there, see how many columns are there, maybe estimate what that size is. Another complicating factor here is the replication factor. So the actual data size is as large as the total size from CS stats or table stats divided by the replication factor. So you may be able to get the size, you divide by the RF, but because these last two items, you may be quite far off. For example, if you have a heavy update or delete workflow, you'll leave these things called tombstones that bloat the SS tables, and that will lead to an inaccurate view of the size. And in order to counteract that, you do a compaction to remove the old SS tables and shrink the storage size, but you need to run that frequently. So let's go into kind of a simple method. So a simple method to determine the size is get a count of all the rows in the keyspace table. And I have a link there, not endorsing one particular library over another, but this one has a ranged read a library. It's written in Java. It's open source. You can go and check it out. And so we're essentially getting a count of all the rows in the table. And with the ranged reads, you have the ability to kind of slow down the rate of reading and only target certain tokens in that token range so you don't overwhelm a single server. And the second thing you want to do is determine the table size. So you can do a describe keyspace to get the replication factor, and then run the no-tool-cf stats command to figure out what the column family total size is. And then if you divide the two, you kind of get the size in bytes, keeping in mind all the caveats we mentioned earlier. So why do you want to do this? Well, I met recently with a customer, and he really wanted to move on to DynamoDB. He was the chief architect, and he said two things. First, Dynamo can never go down. And I'm like, okay, great. Amazon.com runs on Dynamo. EC2 requires Dynamo in order for an EC2 instance to be launched. So we'll check that box. And then the second thing he said, I need to be able to justify, this story. Why are we going to move on to this service? Why are we going to put our time and effort into it? And so by using this method, you can sort of figure out, this is about how much throughput I need. This is what the cost would be. And we have customers like Samsung and GumGum. They report a savings of 70% using the TCO method of after migrating to DynamoDB. And that's not even counting all the man hours and all the extra effort that goes into handling the cluster. It's just based on licensing and usage. So what we're going to do is basically figure out about what the average item size would be in Dynamo. There's a couple methods here. You can take the rows straight out of Cassandra, format them in JSON, send them to Dynamo using, say, one of our AS SDKs, and then ask Dynamo to return how much capacity was consumed. Reads are a little more complicated. If you want to determine how much read throughput you need in DynamoDB, what you need to do is determine the average number of rows coming back from your SQL SELECT queries. Something like Dynamo, we would return thousands of rows back in one query. But hey, what if some of your SQL selects are returning hundreds of thousands of rows? So you can't just look at the reads per second. Reads per second don't give you the full answer. And roughly speaking, if you take the reads per second, writes per second, and if you know what the consumed capacity units are from DynamoDB, you can sort of figure out, okay, I need this many read units, this many write units. So admittedly, there's some complexity here, and the application of this really depends on the customer use case. So now we're going to dig into the best practices for SQL to Dynamo. What should you keep in mind while reviewing your SQL statements? What should you know about how Dynamo Global Tables differs from Cassandra's cross-DC replication? So we're going to talk about things to look out for. These aren't warning signs, but they're important things that you want to know when you're reviewing your queries on the table. So if you're using counter data type in Cassandra, note that Redis is usually better suited for rapid counting. So we're talking hundreds of thousands of reads per second, certainly tens of thousands of reads or tens of thousands of writes per second. You can do this on DynamoDB if you want to use the counter data type. We'll talk more about that later. Another thing you want to look out for is append-only rows. And so Dynamo has a maximum row size of 400 kilobytes. So if you have more than 400K under one key, you're going to have to split that up into multiple Dynamo rows, which is fairly common. Another thing to note is Dynamo uses a consistent hash scheme. So we always must have the primary keys equal to a precise value. And so if you don't actually have that statement, that primary key condition in your queries, then you're going to have to do what's called a scan, and that can be quite slow. It's really no different from Cassandra, but it's important to note. And of course, Dynamo doesn't have any group bys or order by syntax. We order the data on disk using the keys that you choose, such as they're called sort keys, but we don't do any grouping. So if you want to group a lot of rows together, you have to do that on the client side. In addition, you need to look for multiple return rows. So with Dynamo, we can return thousands of rows from one query operation, but the Cassandra rows are wide. So we're talking, you're always just appending columns. The query will hit that maximum response size, and then you need to do a sequential query under that key. So a common example of this is, let's say you're storing time series data in Dynamo, and you're always adding new rows with an ever larger timestamp, because the new data is generated. And in Dynamo, what you'd have to do is say, query this data starting at this timestamp for this device, and we'll return it back, but we can only touch on 1 megabyte of data. And once that response is filled, you have to come back with another query, so that kind of adds some extra latency. Look for anything that looks like if not exists. The great thing is there's nothing to do here. We just want to make a note that those are known as lightweight transactions in Cassandra, and those map to attribute exists. And then we have timestamp data types. Timestamps should be converted to something like an epoch or an ISO A601 format. And if you see a TTL, note that Dynamo TTLs use an absolute epoch, and they're not relative. So you actually have to put a date and time as that attribute using the epoch format when it should be deleted. Important thing to keep in mind is in Dynamo global tables, this is really not well known, and it can be a misconception of sorts. Basically, Dynamo tables use a state transfer, and it doesn't have a conflict-free replicate data type. And so when we replicate data, we make this table consistent. But if there's a conflict, only one of those conflicts will win. And the best example here is looking at counters. So with Cassandra on the right side, if you have a counter in one region and another, you increment it in both, the final value will be 2. It will be additive. But in DynamoDB, if you do the same operation, the counter could be 1 or it could be 2, because what we do is we replicate the state of the row and not basically the effect, not the action that was done to get it to that state. So we have a situation in Dynamo global tables where we will clobber conflicts. So solutions to this include creating a new Dynamo row for each increment with a random sort key. It's not as precise, but it won't clobber. So here's some common questions that we get. We have customers who think we can store time series data in Dynamo. Is there any different? And the reality is that Dynamo is efficient for storing time series data. We also have customers who come from Cassandra and they think Dynamo is like Cassandra when in fact it's not. And they want to know about, do we have compactions? Do we have tombstones? Is there performance impact for issuing deletes? And the answer is no, there's no impact. You can delete as many rows as you want. You won't see a deviation in your latency. Customers will also come to Dynamo and have some kind of issues with consistency. Sometimes customers get burned by it. And Dynamo actually is a really simple consistency model. Every write is replicated to 3 places. We know precisely what the value was that you just provided us. You can do a consistent read in Dynamo and retrieve the data back. And for software architects, this is actually really great news because you don't have to rely on your developers to write this into the queries. It's just by default. Dynamo will replicate your data into 3 AZs. And so you can kind of sleep safely at night. And sometimes customers will look at the 400K row size and say, that's the reason why I can't move to Dynamo. 99% of my data is less than 5 KB, but that last 1% is going to keep me up at night, is going to cause us to buy all these licenses, and that's just not, it's really not what's best for you. So if you're trying to store data in Dynamo, it's larger than 4K, you could put it in S3, you could compress it, you could break it up into multiple rows. So don't let the item size cap keep you from moving on Dynamo. Look at what percentage of your data will fit inside the row. If you have that date time format, go with the ISO A601 and store it as a string, my personal recommendation. This is a really interesting one. The second one, so how long does it take to scale my Dynamo table? And a lot of times they ask, how long does it take to add nodes to my cluster? Well, my question to you is, when's the last time you scaled up your Cassandra cluster? How long did that take? I had customers, one of the largest users of Cassandra, and they're like, well, it takes a couple of days. In Dynamo, we can actually do this in seconds. So if you have a table and you need more provision capacity, we can do it in 10 seconds. If we have to add new nodes, it might take a couple of minutes and a couple new servers underneath. It could take a couple of hours depending on some circumstances such as how much data you have, but generally speaking, it's very, very fast. So when you're looking at migrating to DynamoDB, first step is match the Cassandra data types, come up with any kind of transformations you need to do. The second thing is look at your materialized views in Cassandra, which are mentioned kind of early in the presentation, that table, and those materialized views map to Dynamo global secondary indexes. Look at your read consistency, because that's the only thing you can tune in Dynamo and decide whether you want the consistent read to be true or false. Speaking of true or false, you actually pay for consistent reads, the units that you purchase. So if you set that to true every time for the operations that support it, you'll get your data back, and that's our promise. And then there's a lot of opportunities for other services. So if you're using DataStax Enterprise Graph and Search, well, we have DynamoDB Streams, which provides an ordered set of changes from your Dynamo table. You could feed that into Neptune or Elasticsearch. And then if you need to do any MapReduce, we have a plugin for Elastic MapReduce, and you can export that data to S3. Now we're going to dig into a pattern for live migration. This is one pattern based on what one of our customers did. So what we have here is two phases, two steps. So step one is Cassandra's master. Step two is Dynamo's master. And basically, you only have one master database whenever you're doing a live migration from one to another. And in this simple pattern, what we're doing is requiring a forward migration. So we can't go back, and we always want to make sure that we have one authority for data. So we start by reading and writing only to Cassandra, which is basically turning on the application. The second step is writing data to Dynamo, and either real or dummy data. And this is an interesting one where a lot of customers get the financial approval to use Dynamo, or they get credits, but they don't have approval from security. That's actually not a blocker if you think about it. What you do is you take that sensitive data, maybe all the data is sensitive, you scramble it, you encrypt it, or you run it through a function that basically gives Dynamo the approximation of the data. It's the same size, it sort of looks like it, but there's no customer information in there. You write that to Dynamo. And this is actually a really important stage, because when you're doing this, you're collecting metrics. You know everything, the performance, like the latency, what the errors are, how much percent throughput you're going to need to move on to Dynamo. And then inside step one, you go to step 1.3, we're reading from Dynamo. And so when we're at this point, we're reading and writing from Dynamo because all these steps are additive. And so what you get is a full suite of metrics. And so I have customers who stay here for months at a time. I have customers who try it, then they're consuming too much read capacity, and we go back and review and say, okay, what API calls are you doing? Try to find ways to save you money. And then the second phase of this is Dynamo is the master. So you're reading and writing still to both, but Dynamo is the authority in the case of conflict. So you'll presumably, in this case, read and write to Dynamo first, and then Cassandra's sort of optional. You want to be able to write everything you can to Cassandra until that step 2.2. But for now, as long as Dynamo is available, you're going to be in good shape. And then the final step is when all data is replicated, all data is in Dynamo, you can stop reading from Cassandra. A lot of customers will stay really on step 2.2 for a long time. Essentially what happens in some use cases is, 20% of your data is hot, and that's great because you can read it from one table, maybe it's being modified, you can write it to now Dynamo and Cassandra on the fly, but that 80%, that iceberg is underneath the water, that has to be bulk copied over because it's not frequently read or written. It hasn't been brought up to the application layer. So most of these patterns are going to require a copy, an export of the data. There's a couple of ways to do it. One way is use a SQL SELECT with the token. And so because we know, as we discussed earlier, we have these token ranges, we can do a select from a table and get everything between a particular range. And that's precisely what the library on GitHub did earlier that I linked to. This is one way to do it. I have another customer who writes a Spark job, exports from Cassandra using some plugins that are already available in Spark, and then dumps the data into S3. Then once it's in S3 in AWS, they write another application to stream from there and then load it into DynamoDB. The options are endless. There's many different patterns that customers have used, and this is just one of them. So what we've done so far, we've talked about Dynamo Cassandra. We've estimated the cost, which is important for kind of deciding whether you want to use Dynamo. And we've shown you one pattern for bulk migration. Now we're going to hop into a demo. In this demo architecture, we have this is a developer, which is going to be played by me. And I'm going to deploy my code to AWS Lambda, the Lambda function. And then that Lambda function is backing an API gateway. So I've got a web client that's reading IMDb titles and writing IMDb titles information like, say my favorite movie, one of my favorite movies is Stargate, is back in 96, 97. And that's stored in Cassandra and Dynamo. And as a developer, I can actually choose what step I'm on. Am I step 1 or 2? Is Dynamo the master or Cassandra the master? And then inside there, what is my stage? Am I just reading and writing to Cassandra, or am I in step 2, 3, where Dynamo is my source? I'm only reading and writing to that database. In this design, it's running in an AWS account. The Cassandra cluster has 3 nodes, each of those in its own availability zone. DynamoDB is basically multi-AZ by default. We sit in 3 facilities. I didn't want to confuse you by putting it in the EC2 section, but under the availability zone, but it is essentially in 3 availability zones. So what we're going to do is dig into the application, show you a little bit of code, and then talk about the targets and how we move the migration.
Alrighty, where we're going to start first is by looking at AWS Chalice, also known as the Python Serverless Micro Framework for AWS. I can see why they gave it that name instead of Chalice. Doesn't really understand. It makes me think of Chalice, like medieval times. Anyways, here we go. Chalice is a really cool framework. It simplifies the deployment and development of Python Lambda functions, Python 2, Python 3. By default, like in its design, it's going to create an API gateway API for you to deploy your application to, and it also has hook-ins for Cognito for authentication. It looks for particular routes such as /title or / whatever, and then you put in verbs, and so you can look for a post or a get operation. It also has some really cool other features like integration with CloudWatch events, so you can schedule your Lambda function invocation. You can also hook into bucket notifications, they say when an object is put into the bucket. Of course, also SQS as well. Pretty much any trigger that is supported by Lambda is supported. And it works by, it's a CLI, and it works really with just this primary command, chalice deploy, and then it eventually drops your code into a Lambda function, and then creates an API endpoint, and then you can run your curl command. In our example, we're going to use a get. So today we're going to store, let's actually go and let me show you. So here's the chalice deploy command. I'm just going to run that in the background. And we're going to deploy to our alpha stage. While that's happening, we're going to take a look at the tables. Now, interesting thing here in Cassandra, see Shanxi is the key space and titles is the table name. Now in Dynamo, you just have a table name. You have no schema. You just choose OK. ID is going to be my primary key. As you can see, there is no rows. And then we come over here and we select star from the table, and we see that no data is returned. So earlier I said that you really need to control, what stage, kind of where you're writing your data to one database or to the other in the simple migration strategy. And so we do that by changing the stage number. A stage number is a number between 1 and 6, where 1 and 3, the Cassandra is the primary, and then 4, 5, and 6, DynamoDB is the primary. And so in this simple migration strategy, the primary is always going to get 100% of the reads and writes. And so basically this method and this class help to validate your configuration. So you can really only take a valid configuration. We're not setting a percentage of traffic on in parameter store, which is where we were storing those that configuration option. That's not safe. We really need to be a lot more careful. So for example, at step number 1, the secondary receives 0 traffic. At step number 6, the secondary receives 0 traffic, but now the secondary is going to be DynamoDB right here. And then here in step 3 and 4, the secondary receives all the read and write traffic, but the primary is different between the two, as you can see. And here's what the code will look like. Say you're, posting into the titles API. We're going to create a title, and then we are going to take that body that was passed, a JSON body, and send it to a class that I wrote called persistDB. Now, there's a lot of complexity underneath because it's like an object mapper. It also uses async IO, so we can write to both databases at one time. So there's a lot of depth in this class. It's called create title, this method. We don't really want to go into it, but basically we're creating a title, and we're either operating against 2 databases or against a single database, depending on the configuration. So as you see, our deploy has completed. That was fairly fast underneath the surface, and we have our API endpoints. And I've got a pre-written little curl command that I can run. And as you can see, we successfully wrote to the Cassandra target because our configuration value is 1, and as you can see in the migration step, when it's 1, primary is Cassandra. I also noticed that there is a slight mistake. I am missing the letter E at the end of title. So I need to go here and back to persistDB to create title. I'm going to go and save that. I added an E onto the end. I'm going to set up a quick deploy into the alpha stage. And while that's running, I am going to go back over here. I'm going to modify my stage, and I'm going to set my stage to 4. And when the stage is set to 4, basically both databases will receive the write whenever it comes through. So I'm going to send my API call here, and scroll down, and I see that I successfully wrote the title. Notice the proper spelling. Let me make this a little bit bigger. Title to both databases. And just to verify that I indeed wrote my data, I come over here and I'll refresh this table. I see that I've got a movie, Stargate. I'm a big fan of Stargates. Here from 1994 is the movie when it was released. And then I come in here and I select everything, and I see here that we have exactly 1 row. So the final step is, of course, to move on and set the configuration stage to 6. So if I go in to the migration stage and modify to 6, where I'm going only into DynamoDB, I just wait a second for that to sync. For kicks, I can go in and delete these rows here, and it's only going into Dynamo. I might as well just delete it here as well. And Cassandra, run around truncate command, not exactly the best thing to do, but hey, we just want to quickly drop the data, and then I do a select over here. I verify that there is in fact nothing here. And now I come back and I do my write call one more time, posting in. I successfully wrote to only DynamoDB, and verify the stage is there, verify that the data is here in the Dynamo table, and show you that there's still no data in Apache Cassandra.
So what we've done is look at the demo application. You've seen us operate and make some calls to Dynamo and Cassandra, but all using one REST endpoint. So here's some tips, some things to kind of learn through writing this application. First thing is you always want to have one master database so that you can maintain consistency. Even better, have only one API that you interact with, that you read and write through, and then let that decide where the data needs to be replicated to. As you saw, there's no application deployments to change the read and write throughput percentage, which is to move us from one stage to another. That's really important because you want to be able to say like 5% of your traffic to one database, and then scale that up to 50% and 100%. And you want to be able to do that quickly. The third thing that you notice is that all those configurations are code validated. So I don't just get to say, send so many percentage of my traffic here, so many percent there, and just let it go. In fact, the whole configuration is validated, so we prevent human error. So despite the fact that we can change, go to SSM parameter store and change what stage we're in, the code will download that configuration and verify that it's a safe operation. So that's very important. So what we've seen is that there's no under-the-gun migrations. We expect a bulk export. We don't have to do it all in a 2-hour maintenance window. And that's really where it can come back and bite you. So you want to be able to do it on your own time. And as I explained previously, we only have one migration direction to infinity and beyond. So you can really only move forward in this, and it gets more complex if you want to be able to move forward and backward. So let's talk about what we learned. From my personal experience, the database migrations are really hard. Software development is hard. Building something new is very difficult, and database consistency models are just strange. I mean, you write data and you read it and it may not be there. You go to a different tab of your app and some value changed underneath, and you're like, what happened to this little thing? Like, it's missing. And there's a lot to learn. You have to learn about new services like the serverless application model, Chalice, as in this example. And there's a lot of new services. And a lot of times if you're doing a streaming triggers on Dynamo, you have to learn AWS Lambda, and you have to learn how to configure it and write code in there. And if you want to copy that data out to Elasticsearch for indexing, well, ta-da, and then you get to learn about Amazon Elasticsearch, our managed Elasticsearch service. And the most important thing is that I think it's a cross-functional team that has to come together to make this migration work. You need the ops guys running the cluster or the contractors, you need the developers, and you need the managers. If the managers want to move on to DynamoDB, but the developers know nothing about the service, then we have to come up with some kind of training requirement. A lot of times the ops guys will say, I don't want to be out of a job. It happens whether you're moving from Oracle to Dynamo, Oracle to Aurora, or in this case, Cassandra to Dynamo. Well, the reality is, are you doing something that you enjoy? Do you like working on these clusters? And if so, there are other roles that you can do, other things that you can manage, but the database is something that's critical that must always be up, and that's DynamoDB strength. So enough from me, let's talk about what customers have seen when they moved to Dynamo. So when Samsung migrated to Dynamo, they saw 70% cost savings. They store almost a petabyte in Dynamo, and they have 130 million API requests. So what they're able to do is migrate to Dynamo, which has a footprint worldwide. So wherever their customers are, they can use DynamoDB, and they had higher performance and a lower cost. Another customer, GumGum, they wrote a blog about this, about their migration. They saw read latencies of 2 to 3 milliseconds from inside the VPC, and just a little bit higher for writes. And they had a 65 to 70% TCO savings over Cassandra. So the thing they're most excited about is no additional infrastructure. And in their case, they were running Cassandra 2.2, one of those versions. And the choice was either, okay, do we upgrade or do we buy licenses from the open source version? Do we move to Dynamo? And for them, this was a really wise choice. So in order to learn more, you can dig into this talk here, moving a Galaxy into the cloud. It's available on YouTube. So if you go search for it now, it's about Samsung's migration to Amazon DynamoDB firsthand. And they migrated in this talk, they'll talk about their migration from Cassandra. So it's not just my opinion about why you would move or how you would move. We have a lot of customer stories. This is one. There's also another story from Samsung. So with that, thank you very much for your time. And we're going to dig here into some of the questions that you have provided. And thank you very much for attending the webinar.